Okay, last example, or sorry, example 3. Find the symmetric equation of a line through a point and perpendicular to the line. So in example 2, we had a whole bunch of lines, and you had to get the information from it, like get the two important stuff, like the direction vector and a point. The opposite question is, okay, I'm going to give you information about the direction vector and point. You need to come up with the equation. And this is a good example of that. So I'd like you to find the symmetric equation. I could have asked you the vector equation or the general equation or any of the other ones. Through a given point, in this case the point is 5, 0. And instead of just coming out and telling you a direction vector, I'm going to tell you something about the direction vector. I'm going to tell you that it's, first off, that it's perpendicular to this line. So this line here has its own direction vector. It's not the same as the one I want. Mine's going to be perpendicular to it. But first, let's try and figure out what the direction vector for this one is. So looking at this, I'm going to call it D with a little subscript L for the line that they've called it. It's in parametric form. What's the direction vector of this one? 1, 2. Again, looking at the coefficients on your scalar multiples, your x's or your t's or your k's or whatever. Okay, so it's 1, 2. Now, my direction vector isn't 1, 2. My direction vector is perpendicular. So how do I find a perpendicular direction vector? Well, I showed this to you last unit. We have a little shortcut. If I can tell you this direction vector, you can give me one perpendicular. So what's that? So we'll ask modest Miranda. If the direction vector is 1, 2, a perpendicular direction vector is?
-2 and 1.
Excellent. That's right, good. So it is -2, 1. Remember the shortcut that we did last unit? You take the x and y, switch them, and make one of them negative. So Miranda told us -2, 1. What else could she have said? 2, -1, that's right. Okay, so now we have our direction vector. Great. What are the two things I need to write in the equation of a line? Direction vector and a point. So do I have a point? Yep, I was given the point, right? And so now I need to write it in symmetric form. So be careful of that. Remember, symmetric form is the one that has the x minus something on the top with the direction vector on the bottom. So I'm going to write this. The point is 5, 0. So let's first look at the x spot. What's going to go on the top if the point is 5? X minus 5, that's right. And then what goes to the bottom? Well, it's the direction number from the direction vector. So what's on the bottom? -2 equals, and now let's do the y coordinate. The y coordinate is the y component of the point, so it's y, and you could say -0, but of course you don't need the -0 part, and it's over 1. Now, that's great, and remember, this is the exact form that we need to have it in to be able to read the information. But we don't like it in this form. We don't like the negative on the bottom. So we're going to do sort of the opposite of what we did in the other question. This is the form we need it to be in to get all the information, but when we sort of write it as in the form that we like, we'd like this negative to go on top. If the negative goes on top, this becomes negative, and this becomes positive, which allows me to switch the order. So then it goes 5 minus x over 2. Okay, so it's one of these that the red form is how we get the information, but when we display this equation, we don't want any negatives on the bottom, so I'm going to move the negative on the top, which changes the order, and it becomes 5 minus x. And then the other side, technically, we can just write y. The y minus 0 is not necessary, and you don't have to put over 1. It's understood. And so that's the equation in symmetric. Now, I could have asked you the exact same question, but give you totally different parts to this question. I could say, give me the general form, right? So you'd have to write it out in general form, or parametric version. Or instead of giving you the point like I did here, I might have to ask you to get the point. Just like in this part, you had to figure out what the direction vector was. And that's how these questions get different. Okay? So that's example 3. Example 4 is in your notes, but we're not going to videotape that one. I'll leave that up to you. Or if you'd like to find the answer on how to do example 4, talk to one of these lovely and talented students who are sitting in front of me right now. So that's it for now, and so we're going to say bye.
Bye.
That was very unimpressive, so it has to be much more impressive. Perfect. Thank you.